Alright, today we're talking about indirect proofs and inequalities of one triangle. The objectives for today will be I will learn to write indirect proofs and I will learn to apply inequalities in one triangle. So far we've been talking about, we've done proofs that are involving what's called direct reasoning. And you begin with a true hypothesis and then you build a logical argument to show that the conclusion was true. So what we've been doing is where we've been doing the two-column proofs that have your statements and then you're followed by your reasons. That's what we've been doing. Today we're going to talk about what's called an indirect proof. That's also known as a proof by contradiction. All right. So this is the vocabulary word that you need to write down, indirect proof. And then I'm about to go ahead and define that for you. All right, an indirect proof is a proof that begins by assuming the conclusion is false and continues until a contradiction is reached. Okay, and a contradiction, that's just something where you know that it is wrong based on some given or a definition or a theorem that we've already proved. Okay, so some steps for writing an indirect proof. Step one is you got to identify the conjecture you're trying to prove. Then you want to assume the opposite or the negation of the conclusion is true. And then you want to use a direct reasoning to show that the assumption leads to a contradiction. And then the fourth step would be to conclude that since the assumption is false, the original conclusion must be true. Okay, so those are the four steps that we're going to be using with indirect proofs. All right, and as I mentioned earlier, some helpful hints when you're doing an indirect proof or proof by contradiction, you want to look for things that involve or contradictions that are involving the given statement. Okay, any definitions, postulates, or theorems that we've done in the past. Anything that would show that those things are false. Okay, all right, so now we're going to do a proof by contradiction. All right, and we're going to look at this statement. A right triangle cannot have an obtuse angle. All right, so this right here, a right triangle, that's going to be our hypothesis. That cannot have an obtuse triangle, that's going to be our conclusion. All right, so we're going to say given, and we'll just name some triangle JKL is a right triangle. And so we want to prove that triangle JKL does not have an obtuse angle. All right, and just for reference, I'm going to go ahead and draw us a triangle JKL. Okay, so we're going to make an assumption. We're going to assume the opposite of what we're trying to prove. So we're going to say that triangle JKL does have an obtuse angle. All right, and then just to help us with this proof, we're going to let angle J be the obtuse angle. Alright, so remember that the angles inside a triangle have to always add up to 180. But since this right here is already 90, we know that the measure of angle J plus the measure of angle L has to be equal to 90 degrees. Alright, and then we know then that the measure of angle J is equal to 90 minus the measure of angle L. Okay, now because right here we said that J is the obtuse angle, that means by definition that the measure of angle J has to be greater than 90 degrees, which means that 90 minus the measure of angle L has to be greater than 90 degrees also, since they're equal. All right, then we do some subtraction. So if I subtract 90 from both sides, we get this. So we have to get rid of that negative. So when we do that, the measure of angle L has to be less than 0. And this gives us our contradiction. Inside a triangle, I cannot have an angle that's less than 0. So since this is false, this is impossible, that means that angle J cannot be obtuse. So since this is not true, since my assumption is not true, that means my proof statement has to be true. So therefore, triangle JKL cannot have an obtuse angle. Okay, that would be the how we prove something by contradiction. We were using some algebra, and then we got this contradiction right here. We're saying this angle had to be less than 0, which is impossible. So since this cannot happen, that means my assumption is false, which would then mean that my original conjecture has to be true. Alright, so moving on now to some theorems. The positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angle. So if we have two sides of a triangle that are not congruent, then the larger angle is opposite the longer side. So I'm going to draw a triangle, and we'll call it triangle ABC. And if two sides of a triangle are not congruent, so let's say this one and this one are my two sides that are not the same. And let's say that the distance from B to C is greater than the distance from A to B. Then my conclusion would be, let me redraw this. Okay, if this is going to be my longer side, then the side that's across from it or opposite, which would be this angle A right here, the measure of angle A has to be greater than the measure of angle C. Alright, so if this is my longest side, this is going to be my biggest angle. And kind of the converse of that, if I have the same triangle here, A, B, and C, and I know that the measure of angle A is greater than the measure of angle C. So let's just say that, I don't know, this is 80 degrees and this is, say, 60 degrees. Then my conclusion is going to be that the distance from B to C is going to be greater than the distance from A to B. Okay? All right, now let's look at an example. So write the angles in order from smallest to largest. All right, so if I'm looking at the sides of the triangle, this 20.4, that's the biggest side, so I have to go across. G is going to be my biggest angle. My shortest side is the 17.2. So if I go across here, that means angle F is the smallest, followed by angle H, and then angle G has to be the biggest. All right, now we're going to do the same thing, but we're going to write the sides. So same idea, which means I need to figure out what this angle is first. So let's go ahead and do that. 60 plus 72 plus x has to be 180 degrees. We add that, that gives us 132. Subtracting, we get 48. So this up here is 48 degrees. All right, now, so that's my smallest angle. So segment PQ, that's going to be the smallest. Then after that, we go across the 60, that gives us QR. And then the biggest segment is going to be PR. All right, so again, the smallest angle is across the smallest side. Alright, so moving on. A triangle is formed by three segments, but not every set of three segments can form a triangle. Right? And so this brings us to this next theorem. Okay, a certain relationship must exist among the lengths of the three segments in order for them to form a triangle. So the sum of any two side lengths of a triangle is greater than that of the third side. So what that means is that the distance from A to B plus the distance from B to C has to be greater than the distance from A to C. Any combination. If I add up these two sides, the length of these two sides, it's got to be greater than that third side. So if we did AB plus AC, that has to be greater than AB. And if we did BC plus AC, that's got to be greater than, oops, this should be BC. And this one was going to be bigger than AB. Okay. Any two sides the sum of any two sides has to be bigger than the third side. All right, so let's look at an example of what that means. Tell whether a triangle can have these two sides. So I got to come up with these combinations. If I do 7 plus 10, is that bigger than 19? All right, so 7 plus 10 gives me 17. And is 17 greater than 19? No, it's not. So then, no, this will not make a triangle. Alright, let's look at another example right quick. Okay, same idea. Look, what a triangle can have sides with the given lengths. So is 2.3 plus 3.1 greater than 4.6? So if I add these, that gives me 5.4. Is that greater than 4.6? Yes, that's true. Alright, then we want to look at, say, 3.1 plus 4.6. Is that greater than 2.3? That comes out to 7.7. So yes, that works. We have to look at the third possibility. Have to do 2.3 plus 4.6. Is that greater than 3.1? Well, obviously, this is going to come out to 6.9, which is greater than 3.1. That checks out. So, yes, this will make a triangle. Okay. Alright, and the last example for the day, we want to link the two sides of a triangle are 8 inches and 13 inches. Find the range of possible lengths for the third side. Okay, so there's two possibilities. First possibility is that 13 is the bigger side. And then the second possibility is that the third side is going to be the longest side. So I'm going to let x be the third side. Okay, so two possibilities. 13 is my biggest, so that means then that according to the inequality theorem, x plus 8 has to be greater than 13. Or the other possibility was that 8 plus 13 has to be greater than x. So in both cases, we're going to do some algebra. I'm going to subtract 8 from both sides. This tells us that x has to be greater than 5. And over here would tell us 21 is greater than x. Now I can rewrite this and say x has to be less than 21. Alright, so x has to be greater than 5 and x has to be less than 21. So this is what we call a double inequality, where we would say 5 is less than x, which is less than 21. So if 13 is my long side, then x has to be bigger than 5. But if my third side is the biggest side, then x has to be less than 21. So I have to combine these two to make a double inequality, and this is going to give me my range.